Okay, good evening everyone. So today I will be discussing the circle practice for the quiz for our quiz next week. Notice that the formula that we're going to use are the circumference and the area of a circle, of course. So the circumference will be 2 pi r, and the area of a circle will be pi r squared. And we're also going to use the arc length formula. That will be L equals to theta over 360 times the circumference of the circle, which is the 2 pi r, and then the area of a sector, that will be a theta over 360 and then times the area of the circle. Okay, and we're also going to use one more formula, which is the Pythagoras formula. That'll be c squared equals to a squared plus b squared. So notice that these are the only formula that you're going to use for this topic. Okay, so for the final answer, I would like you to just follow what you get from the calculator. As soon as you see the result from the calculator, just see what you get from the calculator. You don't have to change it into decimal. For example, if you get, for example, like 20, let's say 20 pi like this, you don't have to convert into a decimal number. Okay, so just leave it like that. Okay, let's start from number one. Determine the circumference of a circle if the radius is 10 centimeter. So it's pretty easy. Remember that every time you want to answer a question and for this quiz, you have to write down all the process. Okay, so first of all, you need to write down the formula. Of course, we are going to find the circumference. They'll be c, and the formula is just like 2 pi r, and then just substitute the r because we already know the r is 10, so that'll be just equals to 2 pi times 10, and it'll be just 20 pi. And don't forget, just write down these what do you call it, the unit, which is in centimeter here. And there you go. You don't have to, again, you don't have to change this into a decimal. Okay, that's number one. Let's go to number two. Number one. Number two, determine the radius and diameter of the circle if the circumference is 44 pi centimeter. Again, this is the one that's being given here is the circumference, and we want to find the radius and the diameter. Most of the time, we need to write down the formula first. Okay, so for number two, you're going to have the circumference, so write down the formulas first. Okay. And then write down anything that you know from the question, which is this one, 44 pi. So write down exactly below the c, this c over here, because that's the circumference. That'll be 44 pi, and then equals to 2 pi r. So we don't know the r here. Make r as a subject means that we need to divide both sides by 2 pi, so to get rid of the 2 pi, so that'll be 44 pi over 2 pi, right, equals to r. So notice that we can cancel this pi, right? And then 44 divided by 2 is just 22. So 22 is equals to r, and the unit is going to be in centimeter. Okay, let's go to number three. Determine the area of a circle if the radius is 35. Again, this is pretty straightforward. So for number three, just write down the formula of area, which is the pi r squared. So you only need to substitute the r by 35. So it says 35 squared, and then use the calculator. You will get 1225 pi, right? 1225 pi. Don't forget to write down the unit in here in centimeters, so this is going to be centimeter square. Okay, pretty straightforward. It's quite easy. Okay, number four, determine the radius of a circle if the area is 225 over 4 pi centimeter square. So again, you're going to connect the radius and the area, right? So because the one that's giving is that the area, write down the formula of area. It'll be pi r square, right? And then write down anything that you know from the question, which is this one over here. That is the area. So write that down exactly below the this a, because that is the area. So it'll be 225 over 4 pi equals to pi r squared. Okay, now we want to find the r, so meaning that we should get rid of this pi and also the square. The one that you do first is the pi, because we divide both sides by pi, right, like this. With that, we can like cancel the pi here, so which means that we only have that 225 over 4 equals to r squared. Now to find the value of r, because we have that square here, so we square root both sides, right? So that will be square root of 225 over 4 is equals to r, right? So it's actually, again, it's actually plus minus, guys, but you don't need to worry about the minus, because in here length should also always be positive. So just write down the positive value of the square root of 225, and that will be just 15 over 2, right? And again, because this is in centimeter, so that'll be in centimeter. Okay, so let's go number 5. Find the perimeter and area of the circle of this. This is not a circle, actually. This is a semicircle. Semicircle. Okay, so it's a good idea if you want to find the perimeter to like make vertex like this one, to know where you are going, because when we want to find the perimeter, if you're not used to calculating it, you need to write down when you go from one point to the other. Okay, so the perimeter for this one is going from AB, right, line segment AB, this one over here, and then after that you're going to go from B to A, but going this way, so that is not AB or BA, that is the arc BA. Okay, so notice that if I write down arc BA, means that you are going to go here. Okay, so just write down here for a number for AB, line AB, you know that this is 20, so it's pretty straightforward because this is 20, that's the AB. And then arc BA is this one. This is like half a circle, meaning that we could just like, okay, just multiply half from the circumference, right? And since we know that the r is from here to here, right, so it's half of that, that'll be just 10, so just multiply by this. Okay, so that'll be 20 plus 10 pi, right? So actually this is actually the final result. You can just like put a bracket here and then write it in a centimeter, but if you decided to use a calculator to find what is the final result, if after you combine those two, you can do that actually. There'll be 51.4, 3 significant figures, yeah, so in centimeters. So this one is correct, this is also going to be correct. Okay, so number 6 is the same thing. Again, it's a good idea for you to like mark points like this one here, right? And this is not a circle, this is a quarter of a circle, right? So it's just like 1/4 of that. But actually I forgot to put this is like a 90-degree angle, so that'll be 1/4 of the what they call the circle. Okay, now again, when we talk about perimeter, is just going from one place to the other, so like A to B, right? So that'll be line segment AB, and then B to C, and then you go from C to A, but C is not going to be straight line, it's going to be like this, which is going to be arc of CA, right? So again, we can write down AB. AB is the same thing like BC, because this is also the radius of the circle, of the 1/4 of the circle, so it'll be just 10, and then BC is also 10 over here, and then for the arc of CA, that'll be a quarter, because this is a quarter, so that'll be 1/4 times the circumference of the circle. And we know that this one is actually the radius, right? Because if I just like make this into a full circle, this is going to be the radius, right? Okay, so that'll be just 10. Okay, that'll be 20 plus, again, this is, I'm going to cancel this, that'll be 2 over here, and that'll be plus 5 pi. And then if you want this as the final answer, you need to put bracket in here and then write down centimeter over here. But if you want to make this into a decimal, it's okay, actually it's fine. You can just like put that in the calculator and you'll get 35.7 centimeter. Okay, so that's for the perimeter. And then for the area, right, so for this 5 and 6, actually the same thing. We can just like write down, I'm gonna like make this a little bit smaller because I don't have much spaces in here. Okay, so I'm gonna use this one actually. Yeah, same thing with this one. I'm gonna move that a little bit left and make that into green. Okay, so for the area, right, the same thing. For area is more straightforward actually. For the area, again, we know that we have the, what do you call it, the area of a circle, which is the pi r square, but this is because this is a semicircle and it's half of that, so that will be just 1/2 times pi r square, right? Because again, because this is half a circle. Okay, so for this one, actually, for this one, number 6, it's going to be 1/4 of the area of a circle, right? So again, this is pretty straightforward, so you only need to write down the r value, in here is 10, so it's 10, and then that'll be just equals to, sorry, it's just a square, so 10 square is 100, 200, so it's going to be 50 pi centimeter square. That's it. Okay, this is one is the same thing, that'll be 1/4 and pi, and then 10 square, that'll be 25 pi centimeter square. Okay, scale to number 7. From the image below, calculate minor arc length JK. So if I say minor, means the small one. Remember, actually we have 2 arc, which are this one and also this one over here. If I say minor, means that it's the smallest one, the smaller one. Okay, the smaller one is over here, right? So again, guys, if the question is a major arc, so you're using this arc. Okay, so you're going to find this angle over here first before you go calculate the using the formula. Okay, so in here we have the minor arc, meaning that we're going to use this angle here, 60 degree, and this is as the radius. And as we know that the formula for the arc length of a circle is just equals to theta over 360 times the circumference of the circle. And now in here we know that theta is the angle that is made from the center of the from the center of the circle here, right, from to J and then to K. Okay, so in this question we know that it's pretty obvious, it's 60 degree, so that will be just equals to 60 over 360, and then we know that the circumference of a circle is 2 pi r, so, and then 2, just write in 2, and then pi, and then the r is pretty safer. Again, we have 7 over here, so like this. So if you simplify this, it will be 1 over 6, and then this is 14 pi. And yeah, again, if you want to just put that into calculator, you will get 7. Wait, let me divide this by 2, you get 3, divided by 2, you get 7, so that'll be 7 over 3 pi. And again, in centimeter, just write down like this. Okay, again, that's pretty straightforward. Okay, for number 8, we do this the same thing, actually the same concept, but the only difference is that we're going to find the radius this time. So in here we know that we have this circle over here, and we have like this one. If it doesn't say about minor or major, right, like this one, it means that it refers to the minor arc. Okay, if I say arc length GH is not this one because it doesn't say anything about minor or major, so we're going to find this one over here. I mean, like this is, this 20 inches is that, this line, the length of this arc. Okay, so again, because we're talking about arc length, so we just like write down the formula. That will be L equals to theta over 360 times the circumference. Okay, so in here we can just like this guy here, if it's going to, I mean, like we can expand that because we know that the C is 2 pi r, so you can change that into 2 pi r. I'm going to write down here 2 pi r because that's a formula of a circle, because we're looking for the radius, right? Previously we only have C. In C we don't see any r, right? But that's why we're going to write it down like this, because the circumference, the formula for the circumference is like this. Okay, now let's go and write down anything that we know from the question. In here we have 20 inches. That is this circumference, so write down, not the circumference, sorry, it's the arc length. That will be 20, just put it over here. And then the theta is this one, 120, so that will be 120 over 360, and then multiply by 2 pi r. Okay, so again, it's pretty straightforward. So we want to find the r, so make r the subject, so move everything to the left side, or we can actually like simplify this first. For example, this is, if I simplify, this becomes 1 over 3. Right, so which means that I can rewrite that again as 20 equals to 1 over 3. So again, I'm gonna just like multiply all of them. 1 times 2 pi is 2 pi, so it's 2 pi over 3. Okay, that's it. Okay, and then again, because we want to find the r, so meaning that we need to divide both sides by 2 pi over 3, or multiply it by 3 first, and then you divide it by 2 pi, right? Okay, I'm gonna do it one by one. I'm gonna remove this 3, so meaning that I need to multiply both sides by 3, so that'll be 20 times 3 equals to 2 pi r. That'll be 60 equals to 2 pi r, and then I'm gonna divide both sides by 2 pi. That'll be 60 over 2 pi equals to r. So again, you don't have to change this. You don't have to change this to decimal. Just leave it like that. Okay, so that'll be r equals to 60. But again, you can you need to simplify. Okay, so we can simplify the 60 and 2. So if you divide 60 by 2, you get 30, and if you divide 2 by 2, you'll get 1. So divide this by 2, you get 30. Divide this by 2, you get 1. So that'll be just 30 over pi. In here is inches, so write that in inches. Okay. Let's go to number 9. Here from the image below, if the area sector OBC is 90 centimeters square, calculate area sector OAC. This is not to scale, guys, so you can see that this is a pretty like almost the same angle, right? But it's actually not. But in here we can say that if it's OBC is 90 centimeters square, so OBC is over here, this is 90 centimeters square. Now the question is, what's the sector area over here? So this big X. So we can actually use the area the ratio concept here. So you can just like write down, okay, so X over 150, this one over this one equals to, equals to this one over this one, which is 90 over 120. As easy as that, guys. So because we want to get rid of the because we want to find the x here, so we need to get rid of this 150. So by multiplying both sides by 150, you'll get x equals to 90 over 120 times 150. We can actually cancel this. We can divide both sides by, I mean, like 9 and 12, sorry, by 3 you get 3, and then here divided by 2 you get 4, right? Divided by 2 you will get 2, divided by 2 again you get 70. Okay, so if we calculate this, that will be equals to 150 plus 75 is 225 over 2. There we go, right? Centimeter. Okay, so let's move on to number 10. In here, from the image below, determine the shaded area from the triangle from the image below. Okay, so this shaded area is over here, and we have this 90-degree over here. So basically, this is just a sector area, right? So we can write down area of the sector. And since we know that we have the formula of theta over 360 times the area of a circle, so the area of circle is just pi r squared. So that'll be equals to 90 over 360, because we know that the angle here is 90 degree, and then times pi and then 7 squared. And just like put all of them into the calculator. That'll be just 49 over 4 pi centimeter squared. Okay, question 11, actually the same thing. From the image below, is area 1 is 100 centimeter square. Calculate area 2. So we can actually use again the ratio concept. So this over, so let's say I can write down as theta 1 over area 1 equals to theta 2 over area 2, right? So it's just like the ratio are going to be the same. So theta 1, let's say is this 50, and then the area 1 is this 100 over here, area 1, so 100. That'll be equals to theta 2 is this 120, right? So 120 over, and the area 2, we don't know that yet, just write down a2 over here. So we want to make a2 as the subject. We can just like do the cross multiplication, or we can do something like this first. Okay, we can actually cancel this, right? This is 1 over 2. And then I can like move this here. There'll be 1 times a2, sorry. That'll be equals to this guy going here. There'll be 2 times 120. So 1 times a2 is just a2, right? And then equals to 2 times 120, 120 is equals to 240 centimeters square. That's it. Okay, pretty easy. Okay, next question, number 12. From the image below, calculate the diameter of the circle if the shaded area is 308 centimeters square. Again, we need to, what do you call it? We need to connect what we know from the question. And here we have this one here, that will be the theta. So theta is equals to 45 degree in here. And the shaded area, this area here, the area of the sector in which the angle is 45 degree, is 308 centimeter square. Okay, now in here, most of the time, again guys, you need to write down the formula from the information that is given. We know that we have the area of the sector, so we need to write down the area of the sector, sector area of a circle formula. So if I write it down, there'll be area of a sector equals to theta over 360 times pi r squared. Right, and then we know that the area of the sector is 308, so right down exactly below this one, that'll be 308. And the theta, we know that we have 45 here, so that'll be 45 over 360, and then multiplied by pi r squared. We don't know the r yet, so just leave it like that. Okay, now we can like move it one by one, or we can simplify this fraction over here first. That'll be 1 over 8, right? If I simplify, that'll be just 1, and it's gonna be 8. So I can move the 8 to the left side, and like multiply both sides by 8. You will get 8 times 308, and divide both, because this is just 1, and we know that because we multiply both by 8, so this is gone, right? And that'll be just pi r squared. Okay, now we can actually calculate that. 8 times 308, that'll be equals to 2464. Yeah, 2464 equals to pi r squared. We're not done yet because we're looking for the diameter, right? So we can find the radius first, and then we find the diameter. And let's divide both sides by pi. There'll be 2464 over pi equals to r squared. So again, you don't need to change it into decimal, just leave it like that. Okay, so again, the last one is because we want to make the r as the subject, so we need to square root both sides. There'll be square root of 2464 over pi is equals to r. Since we're looking for the d, right, diameter is like twice of that, so that will be just 2 multiplied by square root of 2464 over pi. Then you can write, just put all of these into the calculator. If you put it into the calculator, you got 56.011268885. So I'm just gonna use one decimal place. That will be just 56.0, and since it's in centimeters, so I'm gonna write that in centimeter. That's it. Next question, number 13. Point O is the center of a circle. Point X, Y, Z are on the circumference of the circle. Determine the value of X and give Y. So X is this one. It's not this X. It's this one over here. So this Y here actually should be here, guys. Sorry. Yeah. Okay, so for this one, because since we know that the point O here is the center point, so which means that this is what we call the center angle. And then if we drag a two line from the this 2 point here and going to the circumference of the circle, like above that, this this angle here is going to be what we call the inscribed angle, right? Okay, so inscribed angle is always going to be half of its center angle. Okay, so inscribed angle, so X will be equals to half of the center angle, which is going to be 60, right? So X is just equals to 30 degrees. That's it, pretty easy. Okay, number 14. Point A, B, and C are on the circumference of a circle, and line AB is the diameter of the circle. So this is going to be very crucial. So since we know that AB is diameter, meaning that if we have this point C is on the circumference, so this is always going to be 90 degree. Okay, so determine the value of X and give the reason again. C is going to be equals to 90 degree because this is the semicircle, right? Semicircle. This is semicircle, this one here, right? So it's always going to be 90 degree over here. So because actually we can use the center and inscribed angle concept. In here we have like 180 degree, right? Remember that the inscribed angle is always half of that. So half of 180 is 90 degrees. So this is going to be 90 degree, right? So that's the one of the concept that we have already learned. Okay, now the next concept that we're going to use to find the angle X here is the sum of angles in a triangle. Okay, so remember that the sum of angles in triangle is always going to be equals to 180 degree. So if I add this angle with this angle with this angle, it's going to be equals to 180. So I can write down an equation for that. There'll be X, sorry, not the equal sign, plus 37, right? X plus 37, and then plus 90 from this one. That'll be equals to 180. Okay, so a pretty simple algebra, right? Just find the value of X. That'll be X. I'm gonna write down here 127 equals to 180. So X equals to 180 minus 127, and X equals to 53, right? Degree. That's it. Okay, number 15. From the figure below, point A, B, C, and D are on the circumference of the circle, and point O is the center of the circle. If angle AOD is 150, what is this? Okay, what is this? Equals 2. Okay, now the first thing that we need to write down here, every time we have like an image like this, like a figure or an image, if you see anything on from the question, you might want to write it down. What's been given here, we have AOD is 150, so write down over here, this is 150 over here, right? And see what's the connection between the one that's being asked. So we know that we have angle AOD, which is a OD, this one is this 108 OD, and then the next one is the angle of ABD, this one over here, ABD is over here, right? So we need to know that one. Okay, so can we see that that is actually the inscribed angle from 150, right? So this is going to be 75. Where do I get the 75? Just divide this by 2, because we know that the inscribed angle is always going to be half of the center angle. So I'm going to write down ABD. Okay, the angle ABD is equals to half of 150. That will be equals to 75. Okay, and the next one is going to be angle ACD. Right, this one. Angle ACD is over here, right? That angle over here. Okay, so notice that that is also the same thing, right? This is also going to be 75 because that is the inscribed angle of this center angle, right? So I don't need to write down anything here. Actually, yeah, you can write down ACD is also going to be half of 150, and it'll be just equals to 75. So the conclusion of this, right? So angle AOD, right? AOD plus ABD plus ACD, that'll be equals to AOD is 150. ABD is 75, and this is also 75, and LB just equals to 300 degree.